All right, problem number 1 asks us to solve the absolute value inequality. I'll write it here, 3x minus 8 plus 8 is less than 5. Other than the empty set, use interval notation to express the solution set and graph the solution set on a number line. Okay, so we've got to solve this absolute value inequality. Our first step to do that is we want this absolute value isolated before we can think about the usual two-case approach that we use for absolute value problems. So let's move this positive 8 here by subtracting 8 from both sides of this inequality. So when I do that, I'm left with the absolute value of 3x minus 8. And 0 is less than 5 minus 8 is negative 3. So now we have the absolute value isolated. We can kind of think about our two cases and what those would look like. So, but before we do that, notice that you have a negative number here on the right side of this absolute value, opposite an absolute value expression. And let's think about what the absolute value means, right? The absolute value measures the distance from 0 on thinking about a number line. So if I say the absolute value of 3 as an example, that equals the output of that is 3, because 3 is 3 units away from 0 on a number line. And I can kind of show that. 0, 1, 2, 3, 4, 5. So 3 here is 1, 2, 3 units away from 0 on a number line. The absolute value of negative 3, is also 3 units away from 0 on a number line. So the absolute value of 3, the absolute value of negative 3, they're both 3. They both output to positive 3. In fact, since we're talking about distance from 0 on a number line, distance cannot output a negative value, right? The distance from 0 can't be negative. It can be 0, right? The absolute value of 0 is 0, 0 units away. It could be 1, it could be 2, it could be 3, it could be 4. 1, 2, 3, 4, but it can't be negative. The absolute value will not output a negative number because we're measuring distance. So thinking about this problem that we're left with here, right? The absolute value of 3x minus 8 is less than negative 3. Now, if I'm thinking about this number line and I'm thinking about less than negative 3 is going to be to the left, right? Negative 4, negative 5, negative 6, negative 7, more negative, right? Every number that's less than negative 3 is a negative number. So essentially what this is saying is the absolute value is less than negative 3. The absolute value outputs something negative because every number less than negative 3 is negative. And like we said, that can't happen. The absolute value will not output a negative. So because this inequality can't be satisfied, this has no solution. Solution is the empty set. So this has no solution. Now so that's the answer to this question, right? No solution. Now what I will say is let's say if this was 3x minus 8 is less than positive 3, right? We can actually try to solve this because this is possible. The absolute value can be less than 3. It can be 2, it can be 1, it can be 0, right? So the absolute value less than a number, that's not negative. That becomes a compound linear inequality. The absolute value less than or less than equal to will become compound in this fashion. This is how we show our two cases. The right side stays the same. And on the left side, that's where we get that negative 3. Because like we said up top, the absolute value of negative 3 does output positive 3. So if this expression, 3x minus 8, is between negative 3 and positive 3, right? If this expression, negative 3x minus 8, is in between negative 3 and positive 3, the absolute value of that will be less than 3. So we can solve this inequality now, this compound linear inequality, by isolating x in the center here. To do that, I'll add 8. And you do that to all 3 sections here. Now, this is all hypothetical, right? This is if it was less than positive 3. This is not what the problem says, but just for argument's sake. Trying to isolate x, so I'll divide by 3. So 5 divided by 3 is less than x, which is less than 11 over 3. Literally, what this means to us is that x can be any value between 5/3 and 11/3. If I plot that on a number line, 5/3 is the smaller number, 11/3 is the larger number. My number line goes from negative infinity to positive infinity. X can take any value in between. This is just less than, not less than or equal to. So, parenthesis, x is less than 11/3, not less than or equal to, so parenthesis. And if I wrote this in interval notation, my solution set starts at 5/3, not including 5/3, ends at 11/3, not including 11/3. So this is a hypothetical solution if this was the absolute value of 3x minus 8 is less than positive 3. So this is hypothetical, but as the problem stands, the correct answer here is no solution.